It's 1 o'clock, I'll start. So hello, I'm one of the Zen.org upstream team, and I'm going to give an overview of some of the compatibility difficulties we face, and which sadly we're passing on to downstream distros. So this is my diagram. So this is an overview of a typical Zen system. So firstly, I need to make a note about the term DOM-naught. This refers to the first privileged guest in a Zen system, which does the work of managing the system and its hardware. It's a bit like the host in other hypervisor systems. So I've drawn a line, I think we can see that, around the code that's upstream at Zen.org, and it comes in two pieces. The biggest part is right down there at the bottom. There's a hypervisor. And the second is this pile of support software, which runs typically in the DOM-naught, in the host, to manage the system and its guests. We call this the tools, which isn't to be confused with the Debian Zen tools package, which is something entirely different. And there are also three important parts of the system for which we're not the upstream. And the parts I'm going to be talking about are the guest over there on the right, QEMU, which comes in a couple of branches, and the DOM-naught kernel. So the most important one, especially for compatibility, is the guest. The point of Zen is to provide a stable and reliable platform and to decouple guest operating systems from the hardware. So we've traditionally given a very strong compatibility guarantee. Guests which are written against earlier versions of Zen are supposed to work on future versions of Zen. So currently we support guests written against Zen 3.0, which was released in 2005. Even more, we aim to support live migration of guests from old versions of Zen to newer ones. So if everything is working well, you should be able to upgrade your Zen host without needing even to reboot your guests. So you can see that's going to be a compatibility promise to meet in practice, which takes a good deal of effort. So almost all of the interfaces to the guest have reasonable extension interfaces, sort of tagged, featured tags, that kind of thing. That's not always sufficient because guests can be buggy, and even quite subtle changes can expose new bugs in guests. But we do try to cope even when that does happen. So in practice, we give forward compatibility for guests an awful lot of thought, and we treat compatibility bugs as regressions which deserve a fix in even much later versions of Zen. The problem with this compatibility guarantee for guests is that it has some serious implications for arrangements for providing a fully emulated x86 PC. And we'll get onto that a bit later. Another big part for which we're not upstream is the Linux kernel. Normally that's Linux. NetBSD supports us as well. We did have Solaris, but the Solaris project not too healthy at the moment. So the interface between the DOM-naught kernel and the Zen hypervisor is much broader than that provided to guest kernels. DOM-naught needs to be able to support all the facilities needed by the management tools to cooperate with Zen to manage the hardware, manage the guests, access guest memory, all those kind of things. And that's the naive way to sort this problem would be to maintain our own version, own branch of Linux with a stable interface. But sadly, given the pace of Linux development, that's completely impractical. So we have a fairly loose coupling where we expect a particular version of Zen to work with a range of DOM-naught kernels. At least we don't have to try to be bug compatible. A user may need to install a version of the DOM-naught kernel with Zen-related bug fixes, even for bugs exposed by a new version of Zen, which has come out well after the kernel was released. In practice, we expect people to get these kernels via their distros, so we aim to push the necessary bug fixes and compatibility changes into upstream Linux stable branches. And that's normally the workflow. So all this means that nowadays you can use the same kernel for your Zen DOM-naught as you would use on bare metal, and indeed in many distros nowadays there's no special Zen kernels. There's just the standard kernels which have the Zen features enabled and any necessary bug fixes included. Now we've time. Okay, there's another important component for which we're not upstream, and that's QEMU. So when we run unmodified guests on x86, we need to provide them with something that looks more like an x86 PC. So it needs to have a VGA display, a keyboard, an ID controller, a network controller, an emulated PCI bus, those kind of things. And we use QEMU to provide that. There's a complication, though. We have a branch of QEMU, which was started a long, long time ago when the QEMU upstream project was not in its current healthy state. And it was essentially very difficult to get changes upstream. So we have what amounts to a partially diverged fork. So we've been aggressively upstreaming the changes necessary to make Zen work into the upstream QEMU. And we hope the new upstream-based QEMU will be the default in Zen 4.3, which will release later this year. So our own branch, which you call QEMU Zen Traditional, is in deep freeze. But you might ask, why does it remain at all? Well, we promised that old guests would continue to run. And the emulated PC provided by modern upstream-based QEMU is quite different from that provided by QEMU Zen Traditional. The device IDs are different, the emulated chipset is different, the new QEMU can't read the save files from the old QEMU, so guests can't be saved, restored, or migrated between these two versions of QEMU. Even worse, there are quite a lot of guests that we want to support which react quite poorly to what would look like a complete motherboard and chassis swap, which is what, from the guest point of view, if you shut it down under one QEMU and then bring it up with a new one, it notices that everything has changed. And even if they don't mind in theory, in practice, the new chipset, the new drivers expose new guest bugs, and then these will be very difficult to work around in the upstream-based QEMU. It might just about be possible to get the upstream code base to emulate the old one, but the nightmarish pile of if-defs, runtime flags, and general horror that will be needed will be very ugly and intrusive and not really suitable for upstreaming anyway. So rather than try to maintain a hideous patch set on top of QEMU to provide like 2 emulation modes, we've decided to maintain the QEMU traditional branch indefinitely, at least so far as we need compatibility for those guests, which will be some time. So that means there's 2 versions of QEMU, the Zen system. New guests get the new upstream-based QEMU, and old guests get the traditional one. Even worse, the speed of development of upstream QEMU is quite high, and it doesn't have a great many Zen-focused committers. So we find that important Zen features and changes can take a little while to get into QEMU upstream. So as an example, support for PCI pass-through, which is an important Zen feature which has been available in Zen and QEMU Zen Traditional for many years, took 6 to 8 months from posting the initial patch set to acceptance upstream. So we have our own version of the upstream QEMU, which contains, which is actually an upstream QEMU with Zen-related changes. We don't commit anything to that QEMU Zen which wouldn't be suitable for upstream, and so all of those patches are probably going to end up in upstream eventually, maybe after a bit of changes. So in theory, the QEMU Zen, as we call it, would be fine for everybody to use in general. But we don't expect the users of distros to want to use our slightly funny QEMU branch, which after all doesn't receive much non-Zen related testing. So the net result is that to get full Zen functionality, a distro needs to include 2 additional copies of QEMU, besides the normal one, and probably they need to have yet another additional version of QEMU for KVM. And one of the versions used by Zen is ancient, to put it mildly. This is not the kind of thing that makes a distro security team very happy. But there's no other way to support those old guests. The price we're paying here is directly related to the support for old guests. And those old guests are often non-free software or in some other way very difficult to modify. So that's the price that has to be paid, unfortunately. So this is one of the key approaches to interface incompatibility. We provide both versions of the software and use whichever one is appropriate somehow. So there's one other difficulty which shows up in this diagram. Zen Upstream, we don't promise that you can run one version of the hypervisor with a different version of the tools. That is, the management software will only work with the corresponding hypervisor. We don't break compatibility within a stable branch, so when we release stable bug fixes and security fixes, there's no compatibility from one release to the next. This is because the hypervisor management interface is complicated and closely dependent on the features available in a particular Zen release. And we keep adding new interfaces for new management interfaces and discarding old ones. And those interfaces are accessible only to the management software and not to guests, so they have much less of a compatibility impact. But still, when you're upgrading, you want to upgrade the tools on your disk and in the on the disk and the file system, and you want to upgrade the hypervisor that's going to be booted at the next boot. If you do this in the naive way with your standard package manager operations, there'll be a time when the two separate files on disk don't match. You'll have installed the new hypervisor / boot and not the new tools, or vice versa. And if you do this, at that point, the system won't work properly if it's rebooted because the sets of packages are incompatible. The system at least remains bootable, but it may well not be able to run any guests. And this also makes it awkward to try out a new version of Zen because you can't easily back in and out and reboot from one version to the other. So we found that some distro maintainers, Debian are an example of this, have arranged to allow co-installation of multiple different versions of the Zen tools. They edit the paths from our make install setup to contain the version number, the Zen version number, and they provide wrappers for all of the externally visible entry points which spot which version of the hypervisor are actually running and run the corresponding version of the tools. This is obviously a bit annoying. So the hypervisor tools interface rule actually seems quite restrictive, and you might argue that it should be more relaxed. But it's not quite clear how much extra effort on our part would help. The most obvious thing we could relax would be to maintain compatibility with different tools versions over multiple different hypervisor releases. Maybe, tools from Zen version N with the hypervisor version N+1. But that wouldn't do very much good. Firstly, because Zen's release cycles are considerably faster than most distros' release cycles, so the whole thing would have to be maintained for perhaps many years upstream, and that would result in each hypervisor containing a great deal more control interfaces, each of which exposes possible bugs. So we're really not gaining much there. And secondly, even if we did that, the distro's package upgrade arrangements still have to be just as complex. So in practice, the capability to co-install different tools versions and use the appropriate set of tools for whichever hypervisor is booted will probably have to remain useful. So there's another big transition in progress. You can see we've got Zendy and libxl there. The old Zendy daemon, which formed the core of many tool stacks, is being phased out. Mostly this is because it's a terrible mess inside the Zen cloud platform, XCP, and various orchestration layers such as OpenStack and CloudStack. And so we're replacing Zendy with a new C library known as libzenlite or libxl. And the command line tool, which a lot of Zen users use, the XM command line tool, is being replaced by a pretty much compatible rewrite called XL. So we've gone some effort to ensure that the interface compatibility here. Existing XM users should find that the guest config files are compatible with the new XL utility. So, and you can use XL from a command line point of view pretty much like XM. So your ad hoc higher level machinery or layers like DTCZen or whatever you have don't need too much adjustment, if any. And we spent considerable effort trying to reproduce ZenD's behavior insofar as we can figure out what it is and it's not hopelessly unreasonable. The results, unfortunately, aren't completely perfect from a compatibility point of view, but we're hoping that the changes that in any particular system will be minor, and at the very least, that that there will be a set of small changes you can make that will leave your system compatible with both XM and XL. So one exception to this is that ZenD had a facility called Manage Domains, where you say XM new rather than XM create. We don't think very many users are using this, and this functionality is much better provided in other ways. So there's a simple init script system which is shipped in the Zen upstream tree, which will start and stop domains from your init scripts if that's all you wanted to do. And if you wanted something more sophisticated with a full-on management interface, then Zappy and its higher layers, such as OpenStack, are a good idea. We also intend libvirt to switch over to libxl. The old libvirt driver breaches a lot of the layering boundaries, which were, to be honest, because the interfaces available weren't sufficient for what libvirt needed to do. So the old libvirt driver talks to the Zen system on too many different layers. So work is going on, particularly in OpenSUSE, to provide a new libvirt driver which is linked against and only needs to talk to libxl, and libxl will provide all the features that libvirt needs. And that's going quite well. So we've been working quite hard to provide a supportable, useful, and complete API in libxl, and to provide feature parity with ZenD, and command line compatibility with XM. This is all coming on quite nicely in the upstream tree. Since Zen.4.2, libxl has had a C programming API, which we intend to support in the future in a backwards compatible way. We're already seeing the first of those backward compatibility features introduced in Zen Unstable. So I think that's the end of, most of what I've got to say. I hope I've given a flavour of some of the challenges we face as the upstream and explained why we've imposed certain amount of pain on downstreams and what the trade-offs are. If anyone has any suggestions for how upstream or distro should do things better or make our lives easier, please speak up or ask questions. Thank you. Yes? So the Zen pieces that are there are two kinds of Zen pieces in Linux upstream. If we're talking, let's talk about Linux upstream. So Linux has got extensive support for running as a para-virtualized support on x86, which is like a guest setup. And that interface for running guests is, as I've described, quite stable. But there's also a second section of support in the Linux upstream, which is there to help Zen manage the hardware, deal with, for example, interrupt management, ACPI, parsing, those kind of things. And the interfaces between that code in Linux and the code that it speaks to in Zen and the code that the tool stack uses to control all that are the interfaces that are really linked more or less ideally to a particular Zen version, but in practice, because of the way that Linux is developed upstream, we provide some fairly loose compatibility there to try to avoid anybody having to, for example, pick a different Linux kernel than they would do otherwise, because we intend for people to have to use whatever kernel they wanted anyway. So in general, when we introduce a new requirement, if we introduce a new feature into Linux, we wait for that to be stable and in the upstream, at least in the Linux master mainline tree, before we start to depend on it in the Zen tree. Anyone else? Nobody even wants to tell us we're horrible. Well, I've justified my position eminently, obviously. No more questions? Yeah.
So what's your take on the other tools that some distros don't even ship, like PV grub images and driver domain images? Like there you have additional QEMU images.
Yeah, well, I mean, there's a trade-off there for the distro. It depends on the quality of the Zen support they want to provide. And the more particularly, I mean, there's no reason for not shipping a PV grub image, because a PV grub image is essentially compatible with anything. It's a kind of guest. So there's not really any difficulty there. And I think if your distro aren't shipping a PV grub image, then that's just a bug, and you should bug in their packaging. But if they're choosing, for example, not to ship QEMU Zen traditional, then yeah, I can see that there's a trade-off they might want to make, and that just means that their users will have that kind of pain with certain of their old guests that may not work right. They may find even that certain guests can't be booted anymore correctly.
Okay, so you don't see that, do you have special advice on shipping like both QEMUs and then two images of these QEMUs as well? Because you have to have the QEMU that runs in .NAR and then the QEMU that runs in a driver domain, which is another binary because it's an image.
Right, that's true. The same source code is compiled twice and produced two binaries in the installed package. But from a support point of view, that's less of a problem, because if you, for example, if you have a security patch that needs to be applied to one of these two QEMU versions, you apply the patch and both will be automatically rebuilt. So I don't think there's any, distro shouldn't really worry about that particular aspect. I know that there has been an effort to try to, some distros have tried to integrate the Zen build arrangement, the QEMU that they use for other people with the QEMU that you used for Zen. And I think, well, I wish them luck in that endeavor. Having a single upstream QEMU is nice. I think our QEMU branch can probably be used for both purposes, but you still need to run it through the Zen build system to build it into this stub DOM image. And the packaging arrangements for processing the source in the right way are tricky. Anyone else? No one? Okay, thank you very much.